So this is how the application looks like. So, as Hanno mentioned, it's browser-based. I can log in. You can run multiple projects in parallel. I already created the qubit project. What you see here then is how to, well, feed the system with documents, so it's sources, and then to do everything with this classification. If I go to this classification page, you see there are no documents in the system yet. So the question is how to feed the system. Here I'm using a connector to the IFI claims database. So I create a new connector, and I want to import the positive examples. And therefore, I take the patent number. So this is the list of 435 positive examples, patent numbers. I paste them here. I do the same for the negative examples. And I create a third set, also for testing and for demonstration. So I query the IFI claims database for the latest 1,000 patents containing the word qubit. Okay, so now the documents, they are imported in the backend. So we are fetching the full text from IFI claims. Then what Hanno said, the first step is to create the category labels. And we do this here in this component label system. So I create a new label called, I already did it before, relevant and not relevant. But you're free to define your own category scheme. Then let's go back to this classification page, and we already see there are documents in there. So there are no labels, so no category assignments yet. We see we have 435 in the negative sets, then 435 in the positive set, and 200 qubits, and this will be further populated in background. So now there are 600. So it takes some time to fetch the data, the full text data from IFI claims. I can also click into one patent here. So you see we have the title, the meta information, abstract, description, and also the claim section. So nothing special here. The second step was to provide training data for each of these categories. So you can go through these documents and label them. You can try to identify good examples for your categories by using the search. Or what we do now, since we already have this information, so we filter for the collection. So I first go for the negatives, 400, and I will label them in a batch. So I can do this on a document level, labeling. So this is not relevant. Then this will appear in blue. Blue means this is manually assigned label. So now I'm going to label all of the patents in this collection. So they are all not relevant. So I save this. This information will now be synchronized with the search index so that you have the filters up to date. So I remove the selection, and we now see there are 435 approved, and the rest is still unclassified. Now I go for the positive examples in the set. Oh, I've forgot something very important here. No. Was just confused whether there are not English documents in there, but this should not be the case. So 430 documents that are relevant. So I label them. Again, this will be synchronized with the search index. I remove the selection. Now I have 870 approved, and this is a distribution. So now this is my training set. So I can now click here on this symbol to train the classifier. And now I make a little bit more detailed. So I go to this classification configuration. What you see here, so first of all, this takes a couple of minutes. So I click on the train button. But what you see, there is a default classifier. So this is a default configuration, which works in most of the cases. You can have multiple classifiers for one project. So you give it a name. You can select the features that you want to use for the machine learning procedure. And usually it's title, abstract, descriptions, and claims. You can set some parameters and make it a single label or a multi-label scenario. I will not go into details here. So the model was outdated, it was training, so I refresh. The model now is ready. And if I click here, then I receive feedback from the system. So we have now 95% precision and recall. How does it work? So this is the result of this cross-validation procedure. So again, the system takes 90% of your training data, trains the classifier, and tests the remaining 10%. And this procedure will be repeated 10 times. So every patent in your training set will be classified and predicted once. So this is how you really get reliable information on how good your classifier is, how consistent your training data is, and whether to maybe add some more training examples for specific categories. So here we can really be happy about the results. I switch back to this classification page. I'm now interested in those documents that are unclassified, 1,000. So they are all the latest 1,000 documents containing the word qubit. Again, I can classify them on a document level, or I classify the whole batch of 1,000. So this takes a short time for initialization, and now we have the first results. Red means a low confidence, rather low confidence. Green means a high confidence. And what low and high means, this is something that you can configure in the configuration. So there was one threshold parameter. The status is unclassified. So if I refresh them, we still have 200 documents that are unclassified. 11, 0, yes, because they are all now auto-classified. And what you then usually do, you go for those documents with a high confidence, then for the relevant ones. And also, of course, you can sort them via the confidence values. So it would be now up to Tony to assess whether these predictions are correct or not.
Yeah, we skipped that section.
Yes, of course. One last thing, maybe because we were talking about using terminologies and how to well, extract concepts and keywords. This is exactly what we did. So we've added another filter with keywords. So these were some terms that have been extracted. So for the relevant documents, it's about, of course, qubit and quantum computing, but also about the superconducting qubits, quantum dot ion trap. And on the other side, if we go for the not relevant documents, then we have something like, well, quantum channel, quantum algorithm. So this, at least roughly, this corresponds to the categories that have been defined. How does this work? So I switched the window here. This is what you see from Patent Monitor if you have administrator rights. So you can configure the search, the text analysis process. Not going to details here, but you can also curate your terminologies. And this is what we did here. We set up a very simple terminology on quantum computing terms. Basically, we used the entries that we found in Wikipedia because we have no other resources at hand. So if you're curating word lists, term lists, glossaries, or whatever you have, so you can upload them to Patent Monitor and use this information for generating further well, filters, content-based filters.